In this video, we'll be looking at the graph of the basic tangent function. We know that the tangent ratio is defined to be y divided by x. So the tangent function is undefined when x is equal to 0. This occurs at any point on the y-axis. So we have asymptotes at 90 degrees, and then 270, and then if we make a complete revolution, we have 450 and 630 and so on. Also, we know that the tangent function is 0 when y is equal to 0, which is any point on the x-axis. So we have zeros, or x-intercepts, at 0, and then 180, and 360, and 540, and so on. So let's go ahead and put those numbers on a graph. We have asymptotes at 90, 270, 450, and so on. So we'll draw our asymptote dotted line. And then we know that we have x-intercepts, or zeros, at 0 degrees and 180, 360, 540. So we have x-intercepts here, 180, 360. And then one other thing that'll help us with our graphing is we know that the tangent of 45 degrees is positive 1, and the tangent of a negative 45 degrees is a negative 1. So halfway in between 0 and 90 is our 45 degree angle, and that value is 1. And then halfway in between 0 and negative 90 is our negative 45, and the value of the tangent function at that angle is negative 1. So we have an asymptote, and we have to go through these 3 points. So our tangent function looks like this. And it's a periodic function, so I'm going to go ahead and draw these other points. And then on this one, we would have a point down here. And let me go ahead and continue on the left side as well. So the red curve is our tangent function. So let's list the attributes. Our domain, since we do have asymptotes, and we're not allowed to use certain angles. Let's go with the radians. Remember, 90 is pi over 2. This is pi, 3 pi over 2. So I'm going to use set builder notation for my domain. It's the set of all x's such that x is not equal to, and I need 1 pi over 2, 3 pi over 2, 5 pi over 2. So notice that the numerators are odd numbers. So we have 2n plus 1 is how we write an odd number, and then multiplying that by pi over 2 will give us our values where our tangent is undefined. And this is for all n's that are integers. Our range, notice we don't have any y values that are undefined. So our range is all real numbers. Let me go with interval notation for that. negative infinity to positive infinity. Discontinuous at my asymptotes, so at theta or x. We're using x here, but I labeled this with theta, equal to 2n plus 1 times pi over 2, for n is an element in the set of integers. We have x-intercepts at x equal to, so this is 0, and then 1 pi, 2 pi, 3 pi, so n pi, and again n is an integer. The period, notice that the period is different for the tangent function. The tangent function repeats itself every 180 degrees. So the period is 180 degrees, or pi radians. And this is different from the sine and cosine. The sine and cosine have a period of 360 degrees, or 2 pi radians. So that's something that we need to remember. And then last, this tangent function is symmetric with respect to the origin. So that means it's an odd function. And that means that the tangent of a negative x is equal to a negative tangent x.